computed the accurate value of nodes, and that is when the block becomes a valid block. Now, like I told before, there are millions of miners in this network. So this network, which consists of say 7 nodes, assume that there are 7 million nodes. So then the scale of miners, the scale of SPV nodes, the scale of full nodes. So imagine in that scale. So there are millions of miners who are competing to find out this node. So whenever, so there is a, I told you there is a block creation frequency which is 10 minutes per Bitcoin. Now every 10 minutes, now like N6, there are million other miners who have a set of valid transactions in their transaction pool. They all start taking the transaction, comment the Merkle root, putting the Merkle root in the header, put the transaction count, timestamp, nonce, start running nonce from 1, 2, etc. And then through the bootstrapping method, they find out the real value of nonce, which makes it a valid block. Okay. So now here, if assume that N6 is a miner who has 1, so N6, what it has actually come up first among a million miners, right? So for it to do this, there has to be some incentive, right? So now remember that previously I told you Bitcoin can come to any node through two means. One is from another node, and second is as a reward from the network. So the reward from the network comes to a miner when he comes first in accomplishing the challenge of creating a valid block by finding a valid nonce value. So now I hope you understood how a node which is having the miner role gets rewarded in the network. Now in case of Bitcoin network, the rewards that the network used to provide started with 50 Bitcoins for every valid block. For every valid block that a miner creates, he used to get 50 blocks. Now this reward used to become half every 4 years. So as of now, it's running at 12.5 Bitcoins for every valid block, right? So now here, since N6 has mined a successful block B5 and has added it to the block B1, B2, B3, B4 after B4, B5 came, so it will get 12.5 Bitcoins if it was today, okay? And this is a valid block, right? Now there's something missing here. We told this is a blockchain, which means it has to connect with block 4. So let's draw block 4 here. So block 4 also is similar, right? It has a header and it has a body, right? And this header has details like this timestamp, transaction, nonce, etc. Now what will happen is we need one more data field here, which is nothing but a hash pointer. Remember we studied about hash pointer as a concept which he used. So this is nothing but previous block's hash pointer, which is also one field within the header. This actually will, like I told you before, hash pointer contains two fields. One is an address. That address will point to the header of block 4, and a hash, which actually will be the hash of block 4's header. Now remember that header and body is separated so that the body is concisely represented by means of Merkle root. So essentially the header alone, if it is connected, it becomes the blockchain. And an explanation or a detail of the Merkle root is the body which contains the transaction. So here in case of block 5, I am going to illustrate the block 5's previous hash pointer here. So this is block 4 header. So it contains a set of details like we are seeing there. Then there is block 5 header, and we have a previous hash pointer which will be nothing but 2 data points. First will be address of B4. So this will point to what is the location of B4 header, address of B4 header, and this will be hash of B4 header. Now the intention of having this previous hash pointer is that anytime when this block gets created, so now B5 is created by node 6, right, which is a miner. Now N6 actually propagates it or floods it to N5, node 5. Now node 5, what it does, it already has block 4. It checks whether block 5 which is coming in has a proper previous hash pointer which links with block 4. If it is not there, then this link is not created, it is not a chain, it rejects the block. So like we have seen here, every node has still block 4 as of now, and node 6 created block 5. So when it gets flooded, when the blocks gets flooded in the network, every node who is going to accept the block is going to first check whether the previous hash pointer does it link to the latest block which is existing in the network. That is what the previous hash pointer is. And if this previous hash pointer is established, then it forms a chain because there is a link between these two blocks. So likewise, as time goes by, B6, B7, etc. gets created. As of now, we are talking about B5. Now we told that the block creation frequency Bitcoin wants to keep at 10 minutes. That is considering the latency that is possible across the nodes, etc. Now the block creation time gets influenced by the difficulty level in the network, right? So there was a condition that we talked about. This condition is what results in a consensus.